I'm Nafata Amabidizuli. Today I would like to show some example for the integration by part. This is the formula. Integral u dv equal to uv minus integral v du. Here's an example. Integral xn cos ax dx n smaller or equals to 2. So, integral x square cos ax dx. We integrate u equals to x square dv equal to cos ax du equal to 2x v equal to sin ax over a. So it becomes integral x square cos ax equals to x square times sin ax over a minus sin ax over a times 2x. X is become x square over a sin ax negative 2 over a integral x sin ax dx. In this example, you have two integration by part. We also have to integrate x sin ax dx. So you become x dv become sin ax du become 1 v equals to negative 1 over a cos ax. So x times negative 1 over a cos ax negative minus negative 1 over a cos ax times 1 dx. We combine it together, so become x square over a sin ax minus 2 over a integral negative x over a cos ax plus 1 over a integral cos ax dx. So the final answer is x square sin ax plus 2x over a square cos ax plus 1 over a square sin ax plus c. This is the final answer. Thank you and see you again.
The first question for question 2 is integration of exponent ax sine bx. Based on the main formula, we need to find u and dv from the equation. So we let u equal to sine bx and dv equal to exponents ax. After that, we need to find du and v. So we differentiate u, which is sin bx, and it will be du equal to b cos bx, and we integrate dv, which is exponents ax, and it will be v equal to exponents ax over a. After we got all of them, u, du, v and dv, and then we arrange all of them based on the formula. After we arrange, and it will be sin bx multiplied by exponent ax over a minus integration of exponent ax over a b cos bx. After that, it will be exponent ax sin bx over a minus integration of exponent ax over a b cos bx. For the integration of exponent ax over a, b cos bx, we need to solve it by using integration by part. So we find u, which is b cos bx, and we differentiate it will be du equal to negative b square sine bx, and we find dv equal to exponent ax over a, and we integrate, it will become v equal to exponent ax over a square. After we got all of them, u, du, v and dv, and then we arrange all of them based on the formula. After that, we got exponent ax sine bx over a minus open bracket b cos bx multiplied by exponent ax over a square and minus integration of exponent ax over a square in negative b square sine bx and close the bracket. And then for the integration exponent ax over a square negative b square sine bx, we can simplify it by putting b square over a square in front of it, and we will get exponent ax sine bx over a minus b exponent ax cos bx over a square plus b square over a square integration of exponent ax sine bx. As we can see at the back of the equation, we got integration exponent ax sine bx, and it's same as the main question. Because it is same as the main question, we don't need to solve it by using integration by part again. We just bring it to the left and we change it from plus to minus, and it will be integration of exponent ax sine bx minus b square over a square integration exponent ax sine bx. After that, because it is minus, we need to make the denominator for the first integration of exponent ax sine bx same with the second one. So we multiply the first one with a square over a square. And then we got a square integration of exponent ax sine bx minus b square integration of exponent ax sine bx over a square equal to exponent ax sine bx over a minus b exponent ax cos bx over a square. After that, we can simplify integration exponent ax sine bx, and it will be a square plus b square multiplied by integration of exponent ax sine bx, and then we bring a square to the right by multiply a square with the exponent ax sine bx over a minus b exponent ax cos bx over a square. And we got a square plus b square multiplied by integration of exponent ax sine bx equal to a exponent ax sine bx minus b exponent ax cos bx. And then we bring a square plus b square to the right by divide a exponent ax sine bx minus b exponent ax cos bx divide by a square plus b square. At the end, we simplify the answer. It will be exponent ax multiplied by a sin bx minus b cos bx divided by a square plus b square.
I will talk about topic integration by part. This is a formula of integration by part. uv minus integrate v du. And this is a table layer. This is a question. Integral a e power of ax cos bx dx. There are two functions here. First, e power of ax, 1 cos bx, 1. Before we start calculate, we need to see what become u and dv. Based on the layer table, e power of ax is exponential, cos bx is trigonometric. Trigonometric is come first before exponential, so cos bx will be u, e power of ax will be dv. And then we need to differentiate of u and integrate of dv. So we just substitute in integration by part formula. After we differentiate and integrate, we just need substitute into integration by part formula. U multiply v minus v multiply du. After we substitute, we need to use IBP integration by part formula again, because here we have two functions are multiplying. Using layer table, we can see negative p sin bx is trigonometric, then it will be u. E power of ax divided by a will be dv. So just integrate this and differentiate this. After we integrate and differentiate, we just need substitute in integration by part formula. First, u multiply v minus v multiply du. It will be like this, and here I just simplify. I take out negative p power of 2 and a power of 2, take out from integral, and it will be like this. This is a new equation from question 1 combined with question 2. Question 1 is from here, and question 2 is from here. So just combine from question 1 and question 2. This is result of after we combine from question 1 and question 2. So here I just simplify from the new equation. After we simplify, we can see it's same calculation with this. So we just need to combine, take this to the left, and it will become like this. I put a power of 2 here because we want the denominator same. After we simplify, we need to simplify again. I just take this and this in one integral. Then it will be like this. Here we just no need to calculate. Next step, I just bring a power of 2 to the right. It's divide, then it will be multiply. Next step, we just multiply one by one. A power of 2 multiply this, and a power of 2 multiply this. Okay, next, we can cancel a power of 2, a power of 2 divide a power of 2, and it will be like this. Here I just we need to take a power of 2 plus b power of 2 to the right. It will be divided because we need leave this integral alone. So here, this is the answer. Here I just simplify on this. I just take out but the same e power of ax, e power of ax. Put in y. Then we write